The overall goal of this procedure is to demonstrate a systematic and efficient arrangement of routine tests of an aprotic lithium-oxygen battery, including an electrochemical test and characterization of the battery materials.
This protocol involves the study of the aprotic lithium-oxygen battery mechanism and the development of battery materials, such as active materials or electrocatalysts on cathode, aprotic electrolyte, and anode materials. The main advantage of this protocol is that it avoids components that can affect electrochemical reactions in lithium-oxygen battery, such as nitrogen, carbon dioxide, and moisture from the atmosphere. It also reduces byproducts such as lithium hydroxide and lithium carbonate.
To begin this procedure, mix previously prepared cathode material and polyvinylidene fluoride, or PVDF, in a 4:1 weight ratio. Add NMP at about 3 times the weight of the mixture. Stir the mixture to make an even-textured slurry. Coat the slurry with a thickness around 100 micrometers onto carbon paper using a doctor blade. Then, dry the laminate overnight in a vacuum oven at 100 degrees Celsius. On the next day, punch the laminate into discs with a hole puncher and weigh them. For aprotic electrolyte preparation, dry lithium triflate overnight in a vacuum oven at 100 degrees Celsius. In an argon-filled glove box.